everyone, welcome to my YouTube channel. I am Sahana, presently studying in Sri Venkateshwara College of Engineering, Department of Information Science and Engineering. And today in this video, I'll be discussing about on the topic of corrosion. Introduction of the corrosion. Corrosion is a process of reaction between metallic surface and its environment. It is an oxidation process. It causes losses of metal and disintegration of a metal by its surroundings chemicals through a chemical reaction on the surface of metal is called corrosion. This is the part of introduction of corrosion. And next, example of corrosion: formation of rust on the surface of iron, formation of green film on the surface of copper, and it is responsible factors for the corrosion of metal, the environmental chemicals, temperature, and the design. And next, the types of corrosions. There are basically 8 types of corrosions, and first one is uniform corrosion, fitting corrosion, intergranular corrosion, stress corrosion, surface corrosion, galvanic corrosion, and last one is erosion. And let us discuss about one by one. What is uniform corrosion? Uniform corrosion, this is a type of corrosion results in uniform and continuous decreases over the entire surface area of metal. This is called uniform corrosion. And what is fitting corrosion? This is localized corrosion, is characterized by the irregular shaped cavities on the surface of metal. This is called fitting corrosion. And what is intergranular corrosion? Boundaries contains metals which shows electrodes potential and rather than other. This is called intergranular corrosion. And fourth one is stress corrosion. Stress corrosion, this is type of corrosion results from combined action of mechanical stress and thermal stress. This is called stress corrosion. And what is crevice corrosion? Crevice corrosion is a localized corrosion of axis. And sixth one is galvanic corrosion. Galvanic corrosion, there are two dissimilar metals with large difference of electrochemical potential. This is called as galvanic corrosion. And last one is erosion. Corrosion in erosion, it is in the making media and moving media is called as erosion. This is the types of corrosions. And next, different theories of corrosions. There are 3 theories of corrosions. And first one is dry or chemical corrosions theory, and second one is wet or galvanic or electrochemical theory. And let us discuss about the first topic, dry or chemical corrosion theory. Dry corrosion theory. According to this theory, corrosion on the surface of a metal is due to direct reaction of atmospheric gases like oxygen, halogens, oxides of sulfur, oxides of nitrogen, hydrogen sulfide, and fumes of chemical with metal. It depends on the chemical affinity of the metal towards reactivities. This is about the dry corrosion theory. And there are main 3 reasons of dry corrosion. And the first one is oxidation corrosion, reaction with oxygen. And second one is corrosion by other gases. And third one is liquid metal corrosions. And let us discuss about one by one. Oxidation corrosion means some of the metal directly react with oxygen in the absence of moisture. This is called as oxidation corrosion. And second one, corrosion by other gases, means it in dry atmosphere these gases react with metal and form corrosion products. This is called as corrosion by other gases. And third one is liquid metal corrosion. In several industries, molten metal passes through metal pipes and causes corrosion due to dissolution. This is called as liquid metal corrosion. And this is the 3 reasons of dry corrosions. And next, wet corrosion theory. It is a common type of corrosion of metal in aqueous corrosive environment. This type of corrosion occurs when metal comes in contact with conducting liquid. According to this theory, there is the formation of galvanic cell on the surface of metals, and some part of the metal surface acts as anode and rest acts as cathode. And this is about the wet corrosion theory. And the chemical in the environment acts as an electrolyte. Oxidation of anodic part takes place and it results in corrosion at anode, while reduction takes place at cathode. Gain of electron in reduction. This is about the wet corrosion theory. And next, the differences between dry corrosion and wet corrosion. In dry corrosion occurs in the absence of moisture, and in wet corrosion occurs in presence of conducting medium. And in dry corrosion it involves direct attack of chemicals on the metal surface, and in wet corrosion it involves formation of electrochemical cells. And in dry corrosion the process is slow, and in wet corrosion it takes rapidly process. And in dry corrosion products are produced at the site of corrosion, and in wet corrosion occurs at anode, but rust is deposited at cathode. And in dry corrosion the process of corrosion is uniform, and in wet corrosion it depends on the size of the anodic part of the metal. And next, factors influencing rate of the corrosion. The nature and extent of corrosion depend on the metal and environment, and the first one is nature of the metal, and second one is environment, pH, oxidizing agent, and third one is temperature, and fourth one is motion. It may cause erosion. These are the factors influencing rate of corrosion. And next, prevention of corrosion. Material selection, proper fabrication and designing, alterations of environment, cathodic metal which is to be protected in is made cathode, anodic protection, surface coatings. These are the prevention of corrosions. And next, material selections. First one electrochemical potential, second one strength, third one thermal expansion coefficient. And designing in corrosion, first one joints, and second one crevices, and third one drainage, and fourth one maintenance. These are the designings in corrosions. And next, sacrificial anode CP method, and second one impressed current CP method. What is sacrificial anode CP method? The metal which has more negative electrode potential than the structure to be protected is connected to electrically. This is called as sacrificial anode CP method. And the application of sacrificial anode CP method: underwater parts of ships, underground power pipes, steel underwaters, and sacrificially protection of steel. This is the application of sacrificial anode CP method. And what is impressed current CP method? An external DC power supply is connected to the metal to be protected. This is called as impressed current CP method. And the application of impressed current CP method: pipelines, underground cables of aluminium, storage tanks, heat exchangers. These are the applications of impressed current CP method. Here you can see the both sacrificial anode CP method and impressed current CP method. And next, comparison of anodic and cathodic protection. First one, applicability. In anodic, active, passive metals or alloys. In cathodic, all metals or alloys. And nature of corrosive medium. In anodic, weak to aggressive, in cathodic weak to medium. And third one is cost. Installation maintenance: in anodic high very low, in cathodic low medium to high. And in operating conditions, in anodic can be accurately determined, and in cathodic determined by empirical testing. And at last, significance of applied current: and in anodic direct measure of protected corrosion rate, and in cathodic complex to indicate corrosion rate. And anodic protection in corrosion: metal to be protected is made anode, and it causes formation of protective film oxide layer on the metals by current. An external current initially applied on the metal so as passivative it. And next, passivating current is minimum protective current from passivation, and in presence of steel, titanium become passive. The primary advantage and its applicability in extreme environment with low current requirements. This is about the anodic protection in corrosion. And cathodic protection: this is the method of reducing or preventing corrosion of metal by making it a cathode and electrolytic cell. This can be achieved by means of externally impressed current or sacrificial anode. An electrolyte is needed to ensure the passage of current through the pad to be protected. This is effectively only in the soils or aqueous medium where pad to be protected is immersed, and it is not effectively in the atmosphere of corrosion. This is about the cathodic protection. Thank you everyone.